Now we're going to look at using two sets of data um, and comparing those using the means and the standard deviation of each set of data. And so let's see what kind of problem we got here. We got Anna is considering two different lineups for her 4x100 relay team. I'm assuming that's 100 meters, 4x100 meters. Four runners, each running 100 meters in a relay race. Below are the times in minutes recorded for each lineup. Compare the means and standard deviation of each set of data. So we got lineup A, and they've got times of 4.25, 4.31, 4.19, 4.40, 4.23. I can tell you right now, this data does not match up to a 4x100 meter relay time, because they'd be running 100 meters in about 10 seconds. So we'd be, we're not going to be running minutes here. I don't know what the 100 is. It's not meters. It's something else. Maybe that's 4x1,000 meters. It might be closer. 1,500 meters is close to a mile. Anyway, whatever. We got the data. 4.18, 4.71, 4.56, 4.32, 4.39. And then in lineup B over here, we got 4.47, 4.68, 4.25, 4.41, 4.49, 4.18, 4.27, 4.69, 4.32, and 4.44. Now we're going to jump over to the calculator, and we're going to run some statistical analysis. We're going to be zeroing in on the mean and the standard deviation between lineup A and lineup B. Now over here on my trusty TI-84 Plus CE calculator, as you can see, I have already entered the data for lineup A. That's in L1, starting with 4.25, ending with 4.39. And lineup B, which starts at 4.47 and ends at 4.40. I'm going to do this a couple of ways because I want to show you something a little bit different. But first we're going to run the stat. I'm going to go back in here to the stat key. I'm going to go to calculate. I'm going to go to the one variable statistics, which is already highlighted. I'm going to hit enter. I see right now it's on L1. So I'm going to hit enter, enter, enter. And I see here that the mean is 4.354. That's with the X and a little bar over it. X bar meaning mean, 4.354. And the standard deviation using the sigma X is 0.161. So I got a standard deviation of 0.161, a mean of 3.54. And we might want to jot that down, make note of that. And now I'm going to go back and I'm going to look at lineup 2. So I'm going to go into stat again. I'm going to calculate again. I'm going to choose one variable statistic again. But this time I'm going to choose L2. And so I'm going to hit second and the 2 button, which is L2. And then we're going to enter, enter, enter. And here we've got a time of 4.42. That was versus 3.54 for the first lineup. And our standard deviation is 0.164, if I round that to the nearest thousandth. If you remember, the other one was 0.162, where they both have a standard deviation, let's say, of 0.16. Well, the other team had a lower mean. The standard deviation is virtually the same. So if I'm Anna and I'm coaching this track team, which is very slow if they're running 100 meters in 4.42 minutes, and they're not going to run it in 4.42 seconds. This is a bad problem that our book is putting together. It doesn't make any sense. However, I am going to choose lineup A because the standard deviations are virtually the same, but the mean is slightly lower with lineup A. Now, If I were really doing this, I would not choose the one variable statistics. I would choose the two variable statistics because I got two lists of data. So I'm going to go back into stat. I'm going to go calculate. And this time I'm going to choose option 2, two variable statistics. And I want to change that X list back to L1. So I'm going to hit second 1 or L1. The Y list, second list is L2. So I'm going to just enter. And I can see here that I got my mean for lineup A of 3.54. My standard deviation is 1.61. The little bar Y, that's my second list, has a 4.42 mean. And if I scroll down just a little bit, I can see the standard deviation for Y is also 1.63. So I can actually gather this same information since I have two sets of data using the two variable stat button rather than going in on each individually and doing the one stat. But again, results are the same. I'm choosing lineup A. Actually, I'm going to get a new track team because if they can't run 100 meters in less than 4 minutes and 35 seconds. You could walk it faster than that. It's ridiculous.